So next up is Josh Bailey, and he's going to be talking about the change in sweet cherry quality with maturity.
Thank you, Beth. Now, I'm sure everyone in this room and viewing from afar have probably divulged themselves in one, maybe two, maybe more bags of delectable cherries, maybe even over the past summer. We're very fortunate in Tasmania to have such close and fast access to some of the world's finest fruits. And why is this? So Tasmania's temperate maritime climate is hugely responsible for this. Among this as well exists stuff like having a fruit fly free status, which allows us to bypass certain biosecurity protocols. This giving us, in Tasmania, a competitive advantage against the rest of Australia. With this competitive advantage has seen increased Tasmanian orchard plantings, and from the figure in the 2018 to 2019 season, you can see that Tasmania produces a quarter of Australia's cherry production, which is quite significant considering our landmass. So while still producing a premium quality product, many things need to be considered, from management of sprays, irrigation, pruning throughout the season, and many more. However, maturity also requires attention. As you can see from the figures, with lapins on the left and cordia on the right, from early development at the top and late maturity at the bottom, the cherries obviously undergo significant biological and morphological changes throughout their maturity. So therefore, the justification for the research is that in this flourishing industry in Tasmania, cherry maturity data and literature is incomplete, not only for Tasmania, but also for Australia and the Southern Hemisphere as a whole. And along with this, quality benchmarking literature is also incomplete for Australia. So this leaves us with some research questions. These include: when do different cherry cultivars develop to their optimal consumer quality attributes? And what happens to these quality characteristics during storage? To assess this, 3 trials were ran. So quality at different maturities is the main trial of this assessment, and we determined many quality characteristics at different maturities for different cultivars. During the lab analysis of these, we just noticed that even on a harvest day, that the colour index would significantly change just from eye appearance, and therefore we wanted to quantify the colour development, and that leads us on to the second trial. We linked this with compression firmness to give a cool chain approach. We also study the anthracene stability over time. This is integral as well because the anthocyanins found in cherries have significant health and nutrition benefits. However, we're still in the preliminary stage of this trial, so I'll only be talking about the first 2 trials with you today. So the methodology includes: we went out to Wannon Valley Farms' commercial orchard in Rosegarland for 11 weeks. 5 cultivars were studied. So we studied Chelan, Cordia, Lapins, Regina and Sweetheart in that order of season prevalence. So 6 trees per cultivar were harvested for 6 weeks based around their commercial harvest date. So this went from 2 weeks before commercial harvest and extended 3 weeks post. So what did we measure? So for 10,500 cherries, we assessed the colour with an Australian standard colour chart. This is commonly used by growers, and we also quantified it with a chromometer. Weight and diameter were assessed, along with compression firmness, which was assessed on a Bioworks FermTech 2 machine in the bottom left. We also assessed flesh firmness and skin puncture force with a gust fruit texture analyzer, as seen in the top middle. We assessed stem retention force with a Mark 10 force gauge, which is seen in the top right. Total soluble solids with a digital Brix refractometer, which is seen in the bottom right. and malic acid content with an automated titrator. So the results. So for each cultivar and for each characteristic, maturity was significant. Therefore, we used a Tukey's honesty significant difference test to assess the difference between the weeks for each cultivar. So regarding size, there are industry standard marks that need to be met to achieve access to those premium markets. So you can see that diameter increases with maturity. This was also analogous to weight. And you can see that maturity is required in this period to achieve a premium weight. Lappens even overextends, and therefore maturity has gone too far and needs to be considered at an earlier stage. Next on, we have colour. So this is one of the two major characteristics along with diameter. So you can see that the colour chart score develops into a maximum, so with 0 being a very, very light coloured cherry and 6 being a very dark coloured cherry. And again, you can see that each cultivar has differing rates of colour development. Just a general trend as well. Generally, these are in chronological order of their season. So Chelan's an early season cultivar, Cordia and Lappin's are mid-season, and Regina and Sweetheart are late. Generally, the earlier, so Chelan and Cordia, reach their ceiling a lot sooner than the other. The late season cultivars, showing that they develop at a slower rate. Next on, we have compression firmness. So as compression firmness degrades quite heavily after the 2 weeks before commercial harvest and has a negative relationship with maturity. Generally, older cultivars had lied within the premium export region for compression firmness, other than Chelan. This is kind of confirmed by literature as well, because sometimes early season cultivars, their compression firmness is to their detriment, so that is confirmed in this study. Next on, we have stem retention force. So when consumers want a cherry, what is perceived as quality is a nice plush green stem, and industry have set this to be around 500 of retention force. So again, you can see it follows the pattern of degradation. However, none are really of concern throughout this trial and is not considered important when deciding maturity. Next on, we have total soluble solids. So this one as well, you can see not only does it take time to reach the premium export range, but it also takes time to reach even the domestic minimum. Again, you can see the general trend of today, different development rates for older cultivars, and again, like the colour, the rate generally decreases when considering early to late cultivars. So conclusions of this trial for this orchard in this particular year. There's a lot going on in this chart, but I've just put where each characteristic for each cultivar met the industry standard line. And for this, I made an optimal harvest guide, and it could be said that you can achieve the best quality cherries for the Chelan 1 week before commercial harvest, Cordia and Sweetheart on the normal commercial harvest date, and Lappin's and Regina 1 week after. This brings me to the second trial, which was quantifying the colour development and the compression firmness after storage. So in the blue, we have low temperature stored cherries, and in the red, we have 20 degrees, or room temperature was the case for this one. And you can obviously see that the storage temperature was critical in retaining higher compression firmness values on the graph on the right, and also slowed down the colour development on the chroma index. What's really interesting about this, though, is that when the chroma index significantly deviates below 21, is the first time when the fruit compression firmness significantly deviates from the industry standard for compression firmness. What's really interesting about this is it's the same case for the low stored cherries. So as soon as the chroma significantly deviated below 21, the compression firmness also significantly deviated from the industry standard. This has implications for cool chain management, as it can be used for a proxy in a less destructive manner to ascertain other quality characteristics. So some conclusions we can draw upon from this trial is that different development rates exist for each differing cultivar. The industry optimal characteristics were generally met within 1 week, give or take, from the normal commercial harvest in this particular year, and that storage temperature is critical to maintain quality. Further research, additional data from different seasons and regions would really strengthen this, and just really add to it and show a better story overall. Even cultivars would be handy. In the scope of an honours project, this wasn't feasible, but sensory panels to assess the quality characteristics would also be very useful and add to this study to be able to quantify the perception of quality from people. And exploring more cultivar-specific cool chain management tools would also be of importance to the industry. I'd really like to thank James Clements and his team at Wandon Valley Farms, and Sally Bound and Nadine Holzell for their guidance and support, Di Murch, Caroline Clay, Ross Corkey, and anyone else who has assisted in various ways. Thank you. Yeah. Ooh,
So the question from Kathy is, how did industry come up with their benchmarks or standards?
Yeah, thanks. It's a really great question. There is a lot of literature that does use sensory panels, and also just really explores what people want in a cherry. And I guess industry really based around those kind of acceptance studies, and then I guess also wanting more of a saleable product as well is quite important. And yeah, achieving that can be a hard goal, but yeah, industry have really kind of set those standards, and it is achieved quite regularly. Yeah.
So the question that Karen's posing is around, well, what do these results mean in terms of harvest times and operational planning and that kind of stuff for commercial growers?
Yeah. Thanks again, a really, really great question. Yeah, it is really, really important and to understand, because then certain management can come into play, and I mean, cherry cracking is quite a problem for the industry, and if seasons, weather, climate is going to affect that and probably cause a high percentage or high occurrence of cracking, that allows the flexibility to, if you can't really achieve the best quality, to also kind of sacrifice it in that way, so you're still getting the best yields as possible.
So Deepa's commenting that in Josh's table there was around when the best times are for harvest, but whether there are some other implications around that from your study. Yeah,
thanks for the question. There definitely are. So that table was kind of just to meet the premium standard. I'll give an example. We were going to study, but COVID restricted it, the anthocyanin development as maturity increased. So anthocyanins accumulate in the skin and the flesh of cherries during development, and have numerous nutritional benefits. So if you wanted to kind of aim it in that way, so to leave cherries on to mature until they develop those sort of anthocyanins, that could be used in further studies, especially with nutritional science and health science. Yeah.
So Dougal's commenting that in some of Josh's results, you can see that for one of the varieties, Shalan, the diameter actually reduces at a point of maturity. What's going on there?
It is a really great question, but I don't know if I have a specific answer. I would have to tee that down to probably the early climate in early kind of mid-December, I guess. Yeah, that's really probably all I can think about for that, is just climate variation, which was probably a bit out of the scope of what I was looking at. Yeah. I don't believe so. No.
So, thank you very much, Josh.
Thank you.
Is Hugh McShane. So Hugh today is talking about the persistence of